Good afternoon, viewers, and welcome to my channel once again. In this lesson, we are going to look at chemistry, in fact, core chemistry. And the topic we are going to treat today is mole concept. Yes. So please, as you are watching, make sure you learn, you practice, and then also you subscribe and then you like my videos. Now, for mole concept, let's say that in our everyday lives, we are used to applying collective terms to describe a number of objects. So for instance, when you hear a dozen, what comes to mind is 12 entities or 12 objects. So when I say a dozen of X, when I say a dozen of X, it means that I'm talking about 12X. The same way, when you hear percentage or cent, the word cent represents what? 100. So you see the total percentage is 100. So it means that the cent or the percentage is a collective term used to represent what? 100 objects or entities. In chemistry, the term mole is also used to describe a quantity of material, but this time around it is made up of 6.02 times 10 to the power 23 particles. So the mole is a collective term used to describe quantity of material made up of what? 6.02 times 10 power 23 particles. And this figure, or this 6.02 times 10 power 23, is also called Avogadro's constant or number. Yes. So, and it is represented by capital N right subscript A. So this is Avogadro's number. Yes. Now let's look at the definition of mole. Now when we talk about mole, we say mole is the amount of substance which contains as many elementary particles as there are atoms in 12 grams of carbon 12. So we are talking about certain elementary particles. Yes. So we are saying that the amount of substance which contains as many elementary particles. So for the elementary particles, we consider atoms to be part of them, consider molecules to be part of them, consider ions to be part of them. Yes. So for atoms, carbon, magnesium, helium are all elementary particles. So you can name them, all the elements. They can all be considered as elementary particles. And molecules, you can consider CH4, that is methane, and A2, that is water. All these are elementary particles. And ions, we can also move ahead to talk about electrons. They can also form elementary particles. So we have, when you talk about one mole of an atom, let's say carbon, one mole of carbon contains what? 6.02 times 10 to the power 23 particles. Yes. So each mole of atom has this number of particles or these particles. The same way, when you consider one mole of molecules, example, when you're talking about methane or water, then we are saying that it also has 6.03 particles. So basically, that is mole. Now let's look at the mathematical representation. So mathematically, amount of substance which we know to be the mole represented by small n is equal to the mass, that is small m, over the molar mass, which is capital M. Now we say the molar mass is the mass of one mole of any substance. Yes. So using their symbols, we say that N is equal to M, small m over capital M. Yes. Now these moles, assuming you have to find the moles given the mass and the molar mass. After finding it, the answer you get, you add the unit to it. So the unit of mole is still mole, but this time around it is m, small o, small l. So assuming that you have calculated for the amount of substance, which is this small n, then you had 6, you add mol to it, small m, small o, small l to it. The same way, mass too is measured in grams. Yes. Then our molar mass is also measured in gram per mole. So when you have to find the molar mass, from here you can still make change of subject. You make capital M the subject. Then after finding the whatever you want to find, you add the unit which is gram per mole to it. And the mass too is in grams. Now let's take an example and solve without wasting much time. Now our first example, what is the mass of 0.5 mole of ethanol molecule? And this is the formula C2H5OH. And we have been given the atomic masses to be hydrogen, the atomic mass of hydrogen is 1, that of carbon is 12, and that of oxygen is 16. So what is the question asking us to do? It is asking us to find the mass of it. Now, from this formula, from this one, we see that N is equal to small m over capital M. So if you want to find m, small m, you have to multiply through by capital M. So multiply this side by capital M, multiply this side to by capital M. So when you multiply the left side by capital M, you get n times m. Then the right side by capital M, the capital M will cancel the capital M there, leaving small m. So small m is equal to small n times capital M. And you know that small m is the mass, small n amount of substance, and this is the molar mass. So we know the moles. It was given in the question to be 0.5 mole, but we don't know the molar mass. Now you have to calculate the molar mass. So in calculating the molar mass, the atomic masses will be very, very helpful. Yes. So now what you are going to do is that the molar mass of this molecule or this ethanol molecule, which is C2H5OH, we say that here we have C2H5OH. So we say we have three elements. We have three elements. What are the elements? Carbon is one element, hydrogen is one element, and oxygen is another element. So the fact that I have hydrogen here does not mean that the elements are four. No, they are the same hydrogen. So we have three elements: carbon, hydrogen, and oxygen. But when you consider the element carbon, we have two atoms of it. When you consider the element hydrogen, we have six atoms. Because this is 5 and this is 1, making 6. We have 6 atoms of that hydrogen. Then when you consider oxygen, we have only 1 atom of it. So we have 3 elements, but we have atoms of each of them. Yes. So what you are going to do is that in calculating for the molar mass of this, given the atomic masses, we multiply the number of atoms given by uh, given for each element by their atomic masses. So realize that for carbon, you have 2 atoms of it. So you multiply that 2 by its atomic mass, which is 12. So the number of atoms for carbon is 2 times its atomic mass, which is 12, plus hydrogen is what? 6. This is 5. Then you come here to, so 5 plus this one, get 6. So hydrogen atoms there, we have 6 times atomic mass there is 1, plus you are left with oxygen. So oxygen 2 is 1. So that the number of oxygen atoms there is 1. So 1 times atomic mass of oxygen, which is 16. Then when you do the computation, you get 46. But you know molar mass is in gram per mole. Now that you have the amount of substance, you have the molar mass. You substitute into this formula. We want to find the mass. The question says you should find the mass. So our mass is going to be our amount of substance, which is in moles, times our molar mass, which is 46 grams per mole. Now, when you cancel mole and cancel mole, you'll be left with grams. So our mass is 23 grams. When you multiply 0.5 by 46, you get 23. Then cancel these moles and this mole. Then you're going to get 23 grams. Now, let's take our last example. So, example 2. Realize that the first one that we solved, we calculated for uh, the mass. Here, we are going to calculate the amount of substance itself, which is the moles. So how many moles are there in 120 gram of sodium hydroxide, that is NaOH? So this is sodium, this is oxygen, this is hydrogen. The atomic mass of sodium is 23, that of oxygen 16, and that of hydrogen is 1. So you code the formula. The mass was given 120 gram. The same way, we are going to find the molar mass. So the sodium is only 1, so 1 times the 23 is here, plus oxygen is only 1, 1 times the 16 is here, plus hydrogen is only 1, 1 times 1 is also here. You get 40 gram per mole. And come back to substitute into your formula. So we say that our mass, which is 120 gram, over our molar mass, which is 40 gram per mole, the answer is 3 moles. Yes. So therefore, the amount of substance is 3 moles. I hope it's understood, and when you constantly practice and solve more questions, you understand it the more. So thank you very much, and subscribe to my channel, like it, and give me comments. That will make me happy.